Hello and welcome to Avantika's Notes. In today's note, we're going to talk about REST APIs, which is one of the ways in which services talk to each other. When you're designing a system, it is important to understand the architecture using which these services are able to talk to each other. Let's say you want to design a food delivery app. When the customer places an order on your app does not go directly and talk to the database to place an order. It talks to a backend microservice that handles orders. But how does your app tell the backend microservice that an order needs to be placed? It does so by calling a REST API that has been exposed by your backend microservice. A REST API is defined as an architectural style for designing network applications that uses standard HTTP methods to access and manipulate data over the internet. Let's look at REST APIs in detail. Taking an example of order service, it has exposed a couple of REST APIs that are used by the food delivery app. Let's try to understand how a REST API looks like and what are its different components. To create an order service has exposed a REST API that looks like this. This REST endpoint has two parts. The first part is called a method and the second part is called a resource. So a resource in a REST API is very important. Resources in your service are like core entities. They are like the nouns or the things of your service. In this case, for order service, the resource would be orders. If it's a user management service, the resource would be users, and so on. REST focuses deeply on things, which are your resources. And then methods define the actions that you want to take on your resource. For example, post, which means that you want to create a new resource. In our case, we want to place a new order. Then there is a method called get, which means we want to fetch some order details. Then put and delete are about updating or deleting the resource respectively. Now let's look at the request body. The request body contains all the data that has to be passed to the backend microservice to save it in the database. You can see in this example, we're passing a restaurant ID, the items, their quantities, and the delivery address. So using this request body, the order service will be able to store the data required for that order in the database. Another important part of a REST API is its headers. So even though we've identified the right endpoint and we've passed the right request body, we may still need to provide some additional metadata so that the server can process this request. For example, we may need to pass some authentication tokens that identifies the user as a valid user, or we may need to specify the content type that we're passing. For example, here we're passing a JSON, or we may even have to specify some custom behavior that the server will use to process this request. All these can be passed in the headers. Headers are not only a part of request, but they're also a part of response. So when the food delivery app calls order service to post order with this request body and the desired headers, server processes that request, saves it in the database, and sends a response. Now let's look at what all things are present in the response. The first part is the response body. Just like request body, this can also be a JSON. In the response, we can see the order service has sent back the order ID, which was created as part of this request processing, and a status that the order has been accepted. Along with the body, it will also send a status code, which implies what has happened with this request. Has it been successful or has it failed? Or was it invalid? Or whatever the status is will be returned by the server in form of a status code. I hope up till now we all have understood how the food delivery app was able to create a new order using the REST API for order creation. Now let's see how it can make use of other REST APIs to see order details on the app. After placing an order, the user would want to see the order details. So the first part of this API is a get, which is a method telling the server that we want to fetch some information. The next part is the resource, orders. And then the third part, which is a new part for this API, is called a resource identifier or a path param. This will tell the server that we're looking to get the information of this resource ID. And that's it. That's everything that the GET request is going to send, along with maybe certain headers. But an important part to note here is that the GET request will not send the request body. It will only send the resource identifier. When the server receives this request, it is going to make a query in the database to fetch the order details for the given ID and then send the response body back. This response body will contain all the details of the order along with the status code of that request, which is 200 in this case. 200 means that this request was successfully processed. Another important thing that a user on your food delivery app can do is see the list of all the previous orders. In this case, the API endpoint would look something like this: get/orders. So we're basically telling the server to fetch the details of all the orders. Once we send this request to the server is going to send a response body back. You can see this is now a list of all the orders that the user has placed. The first one is in accepted state, the next one is delivered, and then the last one has been cancelled. Now, what if the user only wants to see those orders which have been delivered? The food delivery app can now call this endpoint. This is very similar to the previous endpoint we saw, but it has a special filter added to /orders endpoint. This filter is called a query param. Here we are telling that the status of the orders that we want to select should be delivered. So once we call this endpoint, the server is going to send us a response body, which has a list of only those orders which are in status delivered state. A final but a very important aspect about REST APIs is that they are stateless. It means that the server does not remember anything about your previous requests. This allows REST APIs to scale very easily. A client can send multiple requests which may be served by different servers, and the client can still expect them to be processed in the same way. This means that the client also has to send everything in the request that is required by the server to process it. I hope this note was useful and it will help you design or understand REST APIs easily either in your day-to-day work or if you're preparing for system design interviews. See you in the next note. Bye.